providing a platform for industry experts to share insights and for learners to engage with emerging technologies and practices. On that note, I would like to introduce the speaker for today's masterclass. It gives me a great pleasure to introduce Mr. Hemachandra Bhat, the Chief Technical Officer at Maven Silicon. As the CTO, Mr. Bhat leads the technical team and oversees all technical activities. He brings with him over 37 years of experience in personal computer products, embedded systems, and VLSI design. He has deep expertise in product engineering, integrated circuit design, Linux systems, and embedded system architecture. Over the years, he has delivered and deployed numerous products for customers across the USA, Europe, and Asia. Mr. Bhatt holds a bachelor's degree in electronics and communication engineering and a master's degree in software systems from BITS Pilani. He also holds 3 US patents in the fields of AI and robotics. Today, he will be speaking on the topic embedded systems, the brain of every smart device. Throughout the session, I request participants to share questions in the chat box. These will be addressed by the team towards the end of the session. I would now like to hand it over to Mr. Bhatt. Thank you.
Thanks, Lavanya. I will just share my screen. One moment. Is my screen visible?
Yes, sir.
Okay, great. Thank you. So thanks everyone for joining today. The thing I'm going to talk about today is about the embedded systems, which are the brain of modern day gadgets today. So as you see, embedded systems have significantly changed the way which we live today, we work today, and also we travel today, right? So you see embedded systems around you wherever you go today. They have significantly improved the productivity of all the human beings today. They have improved the quality of life. They've also made our lives safe, right? So I'll talk about a few of the things, right? So as you can see, they are very essential elements of our life today. And I'm going to give brief introduction about how they work, what they do, right? Um, and you see many systems today at home, like your washing machine, your dryers, or your microwaves, which we use in your day-to-day lives. The cars and bikes which you use today have a lot of embedded systems in them today. And the IoT enablement has significantly improved the way in which we control or monitor our embedded systems. So now getting directly into the agenda. So I'm going to talk about what is an embedded system, what are the components, how does an embedded system boot up, right? So what's happening under the hood. And embedded system device domains, I'm going to talk about some of the domains where they're all pervasive today. I think I should say that every domain today has an embedded system. And what are the technologies that are influencing embedded systems today, and they're fueling the growth, right? So, and how to go about designing an embedded system, and what are the career opportunities, and what are the critical knowledge and skills that are required to get into this space, right? So without much ado, jumping in, I'm sure you've experienced an embedded system around you today, and I think on everyday life, right? So very simple embedded system to very complex systems. A simple system is your water level in detector, or actually that helps you to pump water into your overhead tanks. I think if you've been using water at your home, then I'm sure you would have seen these systems which basically monitor the water level in your sump tank, and also your overhead tank. And whenever the water level goes down in your overhead tank, they pump the water from the sump tank into the overhead tank. And they also monitor a few things, right? So when the overhead tank is overflowing, they stop the pump. So they're like intelligent, right? So they're not just doing a pumping operation, but they're intelligent enough to do certain things. Otherwise, actually, you would either waste water or waste electricity unnecessarily, right? So they actually help you in that sense to save a lot of things, save water, save electricity. You can see the benefits immediately there. So the most complex system is your autonomous driving system. I mean, I'm sure you would have heard about autonomous cars, which have a multitude of sensors. You have radars, you have lidars, you have GPS system, you have camera, proximity sensor, whatnot, right? So many systems, they come together, and there is an embedded system that is sitting together to monitor all these, right? All these sensors and drive your car autonomously, right? So it's a very complex system. It's not very simple. It needs to understand the road, right, where the road is, and understand where the obstacles are, and understand what kind of obstacles you're seeing. So it's too complex. I mean, it's very complex, or I mean, embedded system, as you see, right? So yeah, it also has to steer your car correctly, and it also apply brakes whenever it is needed, and it also has to accelerate whenever it is needed. So all these things happen based on your sensor inputs, and basically it also monitors and drives autonomously. So that's quite complex, as you see, right? So yeah. So going into some of the examples, so very simple embedded systems, as you see, you use, day-to-day life, right? So mouse, which is a very simple system, which basically monitors the movement, and also sends it to the computer so that your computer can move the cursor on your screen accordingly. Then your digital thermometer, smart light, they are very simple systems. The medium complex systems are like cameras, smart TV, autonomous robots. The most complex systems, which I spoke about just now, ADAS system. I mean, ADAS has autonomous car as the highest level of ADAS level, right? So basically, from simplest, which is no support for autonomy, to the highest level of autonomy, which doesn't need any driver, right? To the rocket. I mean, rocket is again an embedded system which has lot many sensors, which operates on your phone, and basically you know what it is used for, right? So you can see variety and multitude of embedded systems, which are very simple to very complex systems, to medium complex as well. So let's look at what does it the basic elements of an embedded system, right? What are the components? So typically you will have a microcontroller platform, which is, I mean, in an embedded as if an embedded system is the brain of your whole system, the embedded system. The meaning of embedded system, again, embed is itself meaning that it is inside your device, right? So if either your mouse, which you see here, or any of your devices which you see, the car, you have an anti-lock braking system. So you see many of them, right? So which are embedded inside, right? So it is embedded. So then inside that embedded system, you have a microcontroller platform. You can say that that's again a further going deep, which is much deeper brain, which is inside the embedded system, which is a microcontroller platform. We'll see what are the examples of those, right? So which is generally a microcontroller platform is based on a microcontroller, right? So fortunately, I had a privilege of developing some microcontrollers for some of the embedded systems for automotive and some commercial applications, and also develop some embedded systems as well for commercial applications, right? So this contains a microcontroller platform, which may contain mostly a non-volatile memory and a volatile memory. Again, volatile memory is a memory where you basically switch off the system, the data is lost, right? That is volatile. Non-volatile memory is where you switch off the system, the the data is still intact inside the memory. Like if you have ROM and flash, which are non-volatile, SD card is a non-volatile. Volatile memory is the SRAM, DRAMs are volatile memories. So then you have multitude of input and output devices and communication interfaces. So these whole things together form an embedded systems. Now, communication device may or may not be there in some embedded systems, may be there in some embedded systems. There may be different kinds of output devices, different kinds of input devices, and memories as well. So let's go try to understand some of these. So some of the microcontroller platforms, they basically contain many of the peripheral interfaces like I2C, UART, SPI, CAN, USB, Ethernet. There are many interfaces that the microcontroller platforms contain. Typically, they have a microcontroller as an associated logic with a PC on a PCB assembly. Then there are input devices like keypads, touchpads, sensors for different kinds of operations like temperature, pressure, distance. So you can have sensors for many of these things. They basically connect through either GPIO, SPI, ADC, different kinds of interfaces which are connected to the microcontroller, right? So you go into the output devices, they are generally connected to CPU through GPIO. Again, some of them are connected through GPIO, I2C, maybe standard LCD interface, right? LCDs are connected through standard LCD interface. So their display devices could be as very simple devices like, okay, very simple element like a LED, right? So if you just switch on a machine or an embedded system, sometimes they have an LED which shows this system has been powered on, and sometimes there is an LED which shows that okay, this system is working fine, right? So as simple as an LED to 7-segment display, character LCD or LCD. So those are like different display devices which you see. And there are communication devices which connect to your system like router switches, or it could be like connected through either through Ethernet or Wi-Fi. When basically there may be a router could be wired router, or it could be a Wi-Fi router, so which connect you to the external world, right? So the connectivity could be also the interfaces like Zigbee as well, right? So which are very popular in the IoT space. So these are different kinds of components that you see, and which are the popular components which you see. So microcontroller generally has a microprocessor. 8051 has been there for quite a while. I mean, maybe last 30-40 years, I mean, 8051 has been there, more than 30 years for sure. So 8051 has been a very popular low-end embedded microprocessor. ARM has gained huge popularity, right? So from late 90s to early 2000s to today, ARM is maybe all pervasive in many, many devices. That way, RISC-V actually is gaining a lot of momentum. So it has been seen in many devices today, and basically gaining a lot of popularity, which is a open source ISA, by the way, so you can download the spec and actually develop your own microprocessor from that perspective. Whereas ARM, you have to go and buy this ARM microprocessor from ARM Inc., right? So basically you get an IP which is going to be placed inside your microcontroller. Whereas RISC-V, you can develop your own processor and put it in your microcontroller. So, by the way, I mean, as a company, Maven Silicon are interestingly training partners for both RISC-V and ARM. So that I'm proud to say that. Then going into the microcontroller providers, you have many providers today. Popular of them are ST Micro, NXP, TI, Microchip. So you see microcontrollers from there. These companies, microcontroller platforms, you see many of them. BeagleBone Black, which is very popular with a lot of developers. Raspberry Pi, I'm sure you would have heard about these. Nucleo boards from ST Micro, Arduino Uno, ESP32. I mean, I'm sure you would have heard about many of these boards. Which are the popular softwares? And typically, the many of these systems may run either on operating system or not an operating system. When there is no operating system, it is basically called bare metal code, which is typical firmware, right? So there's no operating system. Whereas some of these devices which I spoke about, like Arduino Uno, may run on a basic firmware. Nucleo boards run on basic firmware, whereas BeagleBone and Raspberry Pi run on Linux. And some of the automotive boards from ST Micro may run QNX. QNX is very popular in automotive as a RTOS. So QNX is, by the way, RTOS, real-time operating system. Linux is a general purpose operating system, whereas firmware is very specific to that particular embedded device. Languages which are popular as on today, C++ are quite popular. Python is also popular in some sense, but Rust, I mean, C++ and Rust. Rust is, people call Rust to be the future language that will probably replace many of these C++ kind of languages, because it'll definitely help you in taking care of memory leaks and issues related to the memory. Free memory that is available, which will create a lot of problems and dangling pointers and stuff like that. So Rust is going to be the future. C++ is the current. Python is also used to some extent in some of the Linux-based systems today. So going further, so let's try to understand what happens under the hood, right? So when you just power on to when the system comes up, right? So I'm talking about a Linux system here. If it is a non-Linux system, it will just stop at the second at these two these 2 points which I've shown here. The next slide, it will go into the Linux part of the story, right? So when you just power on, I think this is a very important thing, and maybe people will ask you if you are going into an interview, right? So people will ask you, hey, how does the embedded system come up, right? So what's the magic that is happening under the hood, right? So you need to be able to explain this very well, right? So, and you as an embedded engineer, if you're going into an interview for an interview, you need to understand a microprocessor platform, a good understanding of the microprocessor platform. It's very, very important, and please study this well, right? So when you power on any processors, basically starts from a reset vector, right? It depends on the processor. ARM actually can start from basically zero address or four Fs and four zeros. That's the address, right? It is configurable. And today's more newer processors, right? RISC-V, for example, you can configure the reset vector address. So, but popular addresses, they start from either zero or FFFF0 because you put your ROM or a flash at this address. Because, okay, important thing is your non-volatile memory should be at this address because you need to have a basic code that runs, right? So before you wrote an operating system, because operating system may reside somewhere else. So, but sometimes you may have a SD-RAM put on your board, like your BeagleBone Black or your Raspberry Pi, which has an SD card outside. So here I'm talking about a typical system, like let's take an Raspberry Pi, right? So you start with a reset vector. So basically the access go to the ROM or a flash, and basically you have a basic boot code, right? So which is situated here. And typically what happens is that you have either something called BIOS, which is a basic input output system, which is typical legacy today. And you have UEFI, which is a typical BIOS today that is used today, Universal Extensible Firmware Interface, that is quite popular today. Or you may have a typical boot ROM. When you may not have, in a non-operating system scenario, you may have just a boot ROM. Now the access goes to the typical boot ROM code. So what does this boot ROM code do, right? So it's typically located at the reset vector address. So and typically more again, each processor has different privilege levels of operation. So it starts with machine mode privilege level to start with. So it basically initializes the low level hardware like your clock, you have timers, you have peripheral interfaces, the typical peripheral interfaces, the timer, SPI, UARTs, and stuff like that. So you'll have to basically initialize them, right? So the code initializes that. Then it carries out something called power on self-test. So you need to make sure before you actually boot an operating system, the hardware on your device, right, and the software on your device is properly working. So you carry out what is called power on self-test, right? And if the result is not good, basically you stop there, right? If the result is good, then you actually, what you do is you load something called bootloader. So this bootloader is typically uh, located in a device, like for example, if you take a Raspberry Pi, it is located on your SD card or some kind of a storage, right? Which is a permanent storage again. So basically you load the bootloader, right, before you load the operating system, right? So, and you load the bootloader into the RAM and then transfer the control to the bootloader. That's what happens here. And then what does the bootloader do? So typical bootloaders are U-boot in a typical embedded system, or you go to a desktop system, it may be a grub kind of a thing. Grub is also used sometimes in embedded systems, but very less. U-boot is the most popular one that is used in the embedded system, right? So what does it do? Initialize complex hardwares like USB, PCI, Ethernet, and stuff like that. Enables MMU. In fact, if you want to load an operating system or if you want to run an operating system on a processor, the processor should support what is called memory management unit, right? MMU, which basically helps you to do a what is called virtual memory, basically virtual memory address translation into physical memory address. So basically, virtual memory management is one of the very important tasks of MMU. So I'll not go into the lot of details about that in this session. But anyway, we can go into a separate session, right? So it enables the network stack, storage drivers, and basically it starts off with a command line boot manager, right? So with simple text kind of commands you can run at this level. In fact, you can stop at this level itself and you can run some command line scripts as well. But then if you can make it continue, it locates the OS kernel, it loads the operating system into the RAM. And what it does is it switches from machine mode to supervisor mode here, sets the supervisor mode bit, hands over the control to the kernel. So I'm sure you would have heard about the kernel, which is basically the, let's say, brain of the operating system again, which is basically controlling the whole operating system, right? So then you basically execute the code in the supervisor mode, and when your kernel sets up memory and interrupt management, it initializes the drivers based on your available devices. Again, when you're an operating system, you cannot access the hardware directly from user. So you'll have to go through what is called system calls. So the drivers help you to basically connect your user level to the hardware level. So through the system calls, you can actually request accesses to your hardware, right? So then you basically mount the root file system, start the init process. I'm sure if you basically open your um, Linux boot code and you will be able to see all this, right? Shows user prompt and user logs in, and now basically you are in user mode, right? So this is what happens when you switch on your system, right, under the hood. So starting from your power on to boot ROM, then go to the bootloader, then going into the OS kernel, right? So, and you have the user prompt. So this is what happens, right? So yeah, you should be able to explain this very well when you go into an interview. Now going into different domains, which are basically, I think I should say that the embedded systems are all pervasive today. Any domain you take, embedded systems are there, right? So you take automotive domain, if you take, there are so many embedded systems that are inside the embedded inside the car today, or your even the bikes today, right? So you have a anti-lock braking system which helps you to be safe, right? So they help you. Anti-lock braking system, by the way, helps you to steer even when you applied brakes, right? So that's a very important element, right? So because otherwise, when you apply brakes and when you ram your brakes hard, actually you may topple, right? So your vehicle may topple. ABS actually helps you in that, and basically that's very important. And ABS airbag, then you have door control, you have lighting control, you have dashboard control. So you have so many controls, right? So which are available in your car today. And by the way, with the IoT coming in, right? So you can actually monitor your car, you can control your car as well, remotely as well as on today. And in fact, autonomous driving is the highest level of autonomy that you can see here. Driverless car, by the way. So then coming to healthcare, you see so many devices at your home today, right? So you have a glucometer, you have a pulse oximeter. I think pulse oximeter, I'm sure you would have heard about this device during COVID time, right? So they were asking you to measure your oxygen saturation level, right? So using the pulse oximeter. So it's as you can see, it's so important for you right today, and your device that can measure your BP at home today. So you can find out what's the blood pressure, you can find out your glucose levels. So there's so many devices that are pervasive today, and going further, actually, for the people who basically live on insulin, there are patches which you can apply on your body, which release insulin in a regulated way over the period of time. So you can see the embedded systems become so important today in your day-to-day life. So you don't have to take insulin shots. There are insulin patches, right? So which will basically provide you insulin over a period of time. So that will basically be much more efficient, by the way. So coming to your home, there are so many devices you see around your home. There are microwaves, there are washing machines, your dryers, which you see today, the refrigerators, right? So you can actually control temperature on in your refrigerator. in your normal storage as well as your basically freezer compartment. You can control your temperatures, and you can actually they have also made your life simpler. You can also actually control it remotely as well today. So not just control on the using the buttons on the screen. So as you can see, many of these things. I mean, your rice cookers, by the way. So and air fryers. So there are so many devices which you see around you, right? So which have been helping you and actually have improved your quality of life, I'm sure. Manufacturing, so the robots, basically the robotic arms, which help you, the autonomous mobile robots, which will help you to transport stuff inside your manufacturing facility. Then there are PLCs, right? Programmable logic controllers, which will help you to control your system in the shop floor, right? So you can control your conveyors. You can control the whole system using PLCs. You can program your PLCs and control the whole operation, right? So there are CNC machines which are today mostly digital, and in fact, you can actually control them. You can hook on your Ethernet or wireless connectivity to them, and you can control them remotely as well. So in fact, we had developed the whole the operation of machine tending in one of the applications remotely. I mean, so you can see that you can control the whole process flow remotely, not by just sitting there. So which is possible through embedded systems today. So agriculture is another area which has significantly helped. I mean, a lot of embedded systems today to help you spray your pesticides, seeding, cutting your crops, weeding. So there are so many I mean activities that can be done. In fact, there are farms available today in the Western world, so they're almost quite automated using these embedded systems, right? So transportation, construction. So you can see that everywhere. I think the embedded systems are all pervasive. So yeah, I mean, so what are the technologies that are fueling the growth, right? IoT, which I mentioned earlier. So you can actually connect many of these embedded systems with connectivity coming into embedded systems remotely, and in fact, today you can control many of these things. In during the COVID times, by the way, many of the factories were controlled remotely, and we had deployed some of these systems when I was working in the previous company. So you can track your medicine remote. I mean, basically in COVID, if you know, the vaccine was supposed to be kept in a particular temperature, and if it goes beyond that temperature, you will have a serious problem. We actually created a tracking mechanism for the from the place where it is manufactured to the place where it is delivered, which is a medical store or basically a hospital, right? So we had kept basically tracking of this medicine so that you will know immediately. You can get an alert. We were getting an alert immediately that this particular vial has crossed the temperature, so it's not usable anyway right now. So as you can see how helpful the embedded systems have become with IoT connectivity, right? So robotics and automation, in fact, this has significantly changed the way the things are manufactured. In fact, the robotics is coming into our day-to-day lives today with humanoid robots. Of course, I think I'm sure you would have heard about many of these robots which are responding to you or which are talking to you. But I think they are going beyond that, hopefully in the next few years. AIML, which is basically getting embedded in all these embedded devices. Tiny ML, by the way, is becoming more and more popular. And there are many platforms today available from many of the vendors like Microchip or your ST Micro, where you can actually deploy many of these machine learning algorithms onto your embedded devices. So, of course, the advanced driver assist systems are basically one of the examples. And in fact, I mean, your CCTV cameras, which is available here at home, which can be monitored anywhere, so which can detect humans and actually send you an alert, right? So, AIML, by the way, is significantly changing the way in which you can actually deploy embedded systems. 5G, of course, I mean, this is one of the big things that is happening today. I'm sure most of you have 5G connectivity on your mobiles today. So which is a low latency, by the way, I mean, which is 200x compared to 4G, right? And a much higher bandwidth than 4G, right? So I'm sure you were very, I mean, accustomed to a 4G, but today, many of the metros today and many of the, even the other towns are getting 5G today. So that is actually opening lot many applications which are going to be used by embedded systems. And in fact, you can deploy embedded systems in much better way using 5G technology. So embedded system design flow. So you basically start um, how they are developed, right? In a typical uh, when you go to a company, right? So how they are getting developed. You typically start from a product specification, right? So where you start, you talk to the user, get the specification, you translate that to what is called functional specification, which is basically describing functionality in much more detail. And in fact, you need also non-functional specification, which is very important, which are like performance specification, environmental specification. Like, for example, if you are developing a car, where should it work? I mean, which environment should it work, right? Should it work at minus 40 degrees or should it work at 125 degrees or 105 degrees? What are the temperatures, right? So it's very important to understand because there are class of applications, embedded applications, like there are commercial, there are applications which are industrial, there are automotive, and there are defense and aerospace. So each of them have different environmental conditions which are required to be met. So you need to understand which environment your embedded system is going to work, right? So then you do a requirements analysis to find out feasibility of implementing this product. So then you go into the high level design where you actually finalize some of the systems, like which hardware platform will I use, which operating system will I use, which programming language will I have to use later on for the development, right? So then you basically identify hardware spec and software spec. Then you develop a hardware system, which is going to be like a hardware. You start from a hardware architecture, develop a PCB assembly, and do the functional testing of the PCB assembly. Then for a software, you develop again here, you start with the architecture, you implement the hard software, you do software testing, standalone software testing. Then you do an integration testing. You put the software, what you've developed, into the hardware. You do an integration testing. You do a functional testing of it. You also need to do a reliability testing and also environmental testing, right? So, and there are also a lot of standards that are available today. I'm sure you would have heard about FCC Class C, Class B. So different kind of specifications that you need to meet. And in fact, if you go to automotive, there are standards which you need to meet, right? Even for example, software, you need to meet certain specifications, right? So there are C guidelines for MISRA C guidelines. So automotive has AutoSAR, which is basically how do you develop a system. AutoSAR develops, basically defines that. So you need to basically make sure you comply to all these, right? So compliance testing is a very important aspect for any system. For a typical commercial application, it may not be important, but when you go to industrial, automotive, aerospace, defense, so the compliance testing becomes very important. I mean, in fact, even in typical commercial, there is a EMI, EMC compliance testing which needs to be done because your system should not be susceptible to EMI or EMC, right? So it should not be susceptible, or it should also not generate harmful radiation which can affect other devices. So then very important step which you need to do is field testing. You need to take it to a field, and especially industrial and automotive, defense, aerospace, you need to definitely do field testing, right? Whereas typical commercial application, you may use your alpha customers to actually deploy these systems. Whereas field testing is very important. You take it to the actual field level and make sure you test it in different environmental conditions and test your product in a real life environment. So if you know when the typical life cycle of an automotive development, product development may take more than 1 to 2 years sometimes, right? So you need to make sure you do all these processes And because automobile is used by you for transportation, so you have to be making sure that it is safe for somebody, right? So it goes through so many processes, and it is made ready for you. When you buy, you don't get to know all this, but then when you go back into the life cycle, you will see that. So what are the critical design consideration for an embedded system? First and foremost is cost, because I mean, an embedded system has to be designed with cost in mind, because and of course, I mean, it has to meet the certain specification for that particular embedded system. So you need to make sure you pick hardware components and software components which are just enough for that particular application, right? So you don't want to put Cortex A processor for a mouse design. This mouse design doesn't need a Cortex A processor. You want to use Cortex M, or maybe simpler 8051, or maybe a very stripped down RISC-V kind of a processor, right? So you don't want to use a very high-end system, because the cost of that processor and the systems around it will be very, very expensive for that particular device. Nobody will buy a mouse which is like maybe 20, 30,000 rupees, unless it is something fancy, right? So maybe there are gaming mouses today available at that price, but then a typical usage mouse, nobody will buy at that cost. So it has to be sub maybe 500, 600 rupees, right? So today you will get mouse for that cost. So you need to make sure your cost is very important, and you just put enough amount of hardware and software in that. So because software, why I'm saying software is that software size will determine your memory, your flash, your SD card, right? All of them are more expensive if you have the size of these increases, right? So you need to make sure you keep it to optimum level. Reliability is most important thing. You need to make sure your embedded system works very well, and the testing you do is good enough. And serviceability, because a very important aspect. So how can you actually, serviceability is not just replacement, it's also updates, right? So how can you update, let's say, software or firmware that is sitting on your embedded system much easier, right? So today people are talking about over the air. I think it's been there for a while. Over the air updates for some of the devices, right? Some of the devices you may have to plug it into the system, right? So typically cars, I mean, of course, if you know Tesla, right? So you can enable your features from anywhere. You just pay for it, it gets enabled, right? So you can see the beauty of that, right? So whereas when some of the devices you may have to take it to the service center to get upgraded, some of the things work over the air. So serviceability is very important, right? So if it is safety critical, then high-end systems, then you have to have redundant hardware and software, right? So again, it depends on the type of the embedded system, what you design, so how serviceable it is. So coming to the career opportunities that are available today, there are multitude of opportunities. I've just listed some of them here. They're called with different names, so but then I think newer and newer things are coming up. By the way, on a day-to-day basis. So there are things like embedded system developer, embedded system engineer, embedded software engineer, embedded software developer, embedded Linux developer engineer, IoT developer, embedded firmware engineer, control systems engineer, embedded systems test engineer. Testing is also a very complex thing in embedded systems today. You need to develop a lot of test harness, test software as well. Embedded system quality assurance engineer, validation engineer, application developer engineer, data acquisition engineer, embedded system technical writer. In fact, um, some of the complex embedded systems, you'll have to probably have a lot of documentation, especially you go for defense and aerospace. There's going to be huge amount of documentation. I'm not sure if any of you have worked on embedded. I mean, these areas, defense and aerospace, and a lot of time goes into documentation, because it's very, very important to know later on that how the system was developed. There'll be audits on that, and to make sure it's really usable later on. So you need to have a lot of writing that needs to be done. Industrial automation. software engineer, developer C programmer, Linux application developer, silicon validation engineer. This is another area where you can be an engineer working in a semiconductor company to do a silicon validation, PCB assembly, software validation engineer. So if you see here, I mean, there are many opportunities for embedded system software development, whereas of course the software developer needs to understand good amount of hardware understanding has to be there. So that's where the course has to be properly designed so that you understand the architecture of the system, the microcontroller, how do you connect two hardware systems. A good amount of understanding needs to be there with the engineer, but then you basically there are a lot of maybe 80 to 90% opportunities will be developing of embedded system software, right? So starting from bare metal to Linux kind of software. So looking at this, what are the critical knowledge and skills that you require? I think I told you earlier, I want to reiterate, you need to have a good understanding of a processor-based system, right? Architecture. Yeah, I actually, these are the few questions I ask when I do an interview as well, today as well as in my previous company. Very good understanding of this is very much required, right? ARM, RISC-V, 8051 doesn't matter, but you understand good, you have a good understanding of processor-based system, right? So many a times people have get confused. What is instruction? What is data, right? So I mean, I'm just giving an example. You need to have a good understanding of what that is, right? So what is code? What is instruction? What is data accessed by the processor, right? So what are the different typical architectures of a processor when it is accessing memory, right? Memory architecture. So you need to have a good understanding of this. And the next very important thing is C++ programming. You need to be a real good programmer. And here in embedded system, very important things for you to understand is pointers. You need to have a very, very solid understanding of pointers, how the pointers work, how do I use a pointer, because this is fundamental to your programming of embedded system, which is not so important when you go to a typical application level programming, but here it's very important. You need to have a good understanding of structures, and of course, pointers will be there in structures as well. Structure pointers, they come together. Functions, good understanding of how to write functions, because you'll have to make sure your code is modular. If you don't understand how to write a function well, then you will have a problem because you write a full monolithic code, which is not an industry grade code. So nobody writes a monolithic code. There's no one file for the whole project, right? So there are multitudes of files which are compiled together, right? Which are connected together. So that's how, I mean, programming is a very important thing, but how to do industrial level programming is very important also. I told about structures. I told about bit fields, right? So how do you save memory? So you need to understand how to write bit fields, the structure, bit fields, unions. So this is very important for you to understand, right? So otherwise, what will happen is that when you go into the interviews, you will actually face a lot of issues. So RTOS or Linux system programming, you have a good understanding of this, right? So it's very important because today most of the embedded systems are moving towards either an RTOS or a Linux, right? So Linux is gaining popularity, but a lot of RTOS based systems are available today. For example, if you go to automotive, you will find QNX as the most preferred operating system today, right? So depending on, I mean, some of the Linux systems inside the, let's say, car, maybe, for example, your audio video systems may have Linux based systems, but most of the other systems will mostly use an RTOS like QNX or otherwise. So it's where or basically free RTOS is also available today. So you can, I mean, use free RTOS or good understanding of free RTOS or Linux system programming. If you can get good understanding of Linux system programming, it basically a superset compared to an RTOS, but at least you have an RTOS understanding. And you do some at least 2 to 3 solid projects in your coursework, right? You need to do this very well. And you need to have a very deep understanding of the completed projects, whatever projects you have done. Don't just write this on your resume. make sure you have done it really well. You understood the project at depth. So first thing anybody will ask you is write a block diagram of your project. Many a times I've seen people don't know what is the block diagram of their project. So once that is that is done, then the next question I'll ask is how did you connect these systems together if there are multiple systems? So yeah, so if there's a LED or a LCD or whatnot, right? So how did you connect them together? How did you make sure they work together very well, right? So then next question will be what kind of code did you write, right? So how did you architect it? What was your architecture? How did you make sure your code works well? How did you test it, right? So basically you need to have a very good understanding of your project. Make sure this is why this is a very critical thing as well. Processor, C programming, RTOS or Linux programming, deep understanding of your project. Then in most of the interviews, the interviewer will test your problem solving ability. They will give you an impromptu problem and ask you to solve that, right? So you need to go about how do you solve the problems. See, if you want to solve the problem, first of all, you need to understand the problem. That's where most of the interviewees fail, right? So they don't ask enough questions to understand the problem statement, right? And they start solving the problem and then get into a lot of issues. So understand the problem statement first, ask questions, right? So that's when the interviewer will understand have you understood the problem well, right? So with your questions the interviewer will understand. So then of course you go about the process. What are the components required, how do I put it together, what is required, and then of course if they ask you to write the code, make sure you write the structured code, right? So I told you structured code, it's very important. So make sure you basically follow some coding guidelines. I'm sure today there are MISRA coding guidelines available. You can actually follow any of them, right? So when you write structured code, the interviewer will be really, really impressed and they will see that you're actually at the industrial grade, not just academic grade, right? So basically, I think very, very important thing to make sure you impress the interviewer. And the last but not the least at all is oral communication. You need to have a very good communication. Many people think communication means just English. It is not. Communication is everywhere. Have you basically understood the other person, what the other person is saying? Are you listening attentively? Basically, and are you asking the right kind of questions? Are you able to understand what the interviewer is saying? So all these are part of your communication, right? So the interviewer will judge you based on all these. So it's not just English. I mean, if you make some English mistakes, right? So don't just worry about that. But are you able to communicate well? Are you able to impress the other person, the interviewer, with what you're saying, right? So that's going to be more important. So I think, yeah, that's pretty much what I wanted to say about embedded systems, how they are used today, and what are the components. What is really, I mean, what are the different domains, and what is fueling the embedded systems today? I mean, and also what are the opportunities today, and also how you can prepare very well, right, for the embedded systems. So that's all I wanted to say, and I will now hand it over to Deepika, I guess. So Deepika.
Thank you, HRB. Hi, everyone. Good evening. Okay. So, thank you so much, HRB, for taking us through embedded systems and give me a moment where I will quickly introduce about ourselves, Maven Silicon, and then we will pick again in the chat box. I have been seeing many questions, and a trainer is already addressing those. And all the questions I will address it now, and I will tell you where you can access this masterclass recording, everything. All right. So quickly, starting with Maven Silicon. So Maven Silicon is a leading VLSI and embedded system design training partner, bridging the gap between academia and semiconductor industry with cutting edge curriculum and hands-on training. Right. So with over 5,000 plus engineers placed in the top semiconductor companies like Intel, Qualcomm, Samsung, we have 250 plus industry hiring partners. Along with that, we have also collaborated with 1,000 plus institutions across India so far. And we are proud to say that we are shaping the next generation of semiconductor professionals, right? And also recognized by National Skill Development Corporation, NSDC, which is our training partner. Also, global leaders like UK, Risk5 International, Altera USA. Maven Silicon is committed to the delivering industry relevant world class training. Also, we have flexible training via online, offline, blended learnings format. Also, we are very happy to announce that we have been honored as a Company of the Year in EdTech 2024 by Outlook Business. We continue to empower our learners, professional, excel in fast evolving semiconductor industry. That's the main motto. And also, Maven Silicon is very active on the social media platform. We release our blogs on excuse me, all these platforms like Maven Silicon, Risk International, SemiWiki, Design and Reuse, and LinkedIn platforms, right? Along with that, I also wanted to quickly share my screen. Hi, Chabi.
Yeah, SWAYAM Plus courses. Yeah.
Yes.
Okay.
Regarding the SWAYAM Plus courses also, these are our, we have uploaded many of our courses in the SWAYAM Plus platform it also. So where we have the free courses and paid courses available with us. And also, I wanted to share the screen for a second. I wanted to show them where they can access the recordings.
Sure, I will.
I hope my screen is visible.
Yes, it is.
All right. Thank you, Lavanya. Yeah. So this is the Swayam Plus platform. I hope all of you are aware about it. And here, if you just go to student in Masterclass, if you go to complete it, you will be able to see the recording of this session. This will be updated within a week of time. And also here in the student, if you go to courses and if you select the partner as Maven Silicon, you will be able to see the courses uploaded by us. So if you see here, we have our courses listed in Swayam Plus platform. And also for few paid courses, there is the credit availability as well. So you guys can go explore all the, there are free courses as well. After that, you can get access for paid courses also. This is how it is visible. So you can go explore in the Swayam Plus platform as well. All right. And yes, so that's it. And if you guys are interested in more courses, if you want to know more about the courses, about Maven Silicon programs, everything, you guys have the email IDs here. If you want to know more about other courses also, you can reach out to the Swayam Plus team. And if you guys are interested towards VLSI and embedded, you guys can reach out to Maven Silicon. There is the email ID admission@maven@silicon-com. Also, I've captured a QR code here for your reference. If you just scan this QR code, you will be able to easily access the courses which is there listed in the Swayam Plus platform. This is about us, guys. And also, I have been seeing in the chat box, many of you are asking about the PPTs, right? PPT we would not be able to share. However, you guys can access the recordings after a week in Swayam Plus platform itself. All right. Any other questions for us? So we'll be able to happily take that and address to you all. Okay, I have one more important question many of you have been asking for. Masterclass, will not be having the certificate, guys. If you want certificate, you can also enroll to our free courses. If you complete them, you will be able to get the certificates. All right, I'm done, Hitabi. Over to you again for all the Q&As. Most of the questions are already addressed by Sushmita. Sushmita, anything you wanted to highlight and wanted to discuss in this session?
Yeah, hi Deepika, and yeah, thanks. Good evening, everyone. We have our CTO here, Mr. Hemachandra, and he has given a very insightful session, and he has the embedded training, and yes, he has really shared a lot of things, and I'm sure I was able to see that people were able to correlate with that, and they were able to put it across in the chat box, and I've tried my best to answer some of the questions. There is one question which is highlighting multiple times, but I tried my best, but might be the person is not satisfied with that. So there is a question. It's like, what exactly is a threat when it comes to embedded industry? And one more question is cybersecurity. Sir, can you try to take it up? I could not answer this part properly, so might be they are putting it across again.
Yeah. So yeah, I mean, I'm assuming when I say threat, it's basically somebody is hacking into the embedded system, right? So basically there is a lot of security. In fact, secure embedded systems is one of the things that has come into the place today. So in fact, even your application has to, if it has to run, for example, in an automotive system, for example, some application has to control, let's say, your brakes, right, or braking. So if it has to basically access the brakes, it has to do something called key exchange. Basically, it goes through the encryption decryption process. If you know about the security that can be incorporated using encryption decryption, right? So in fact, that is already implemented. So you need to basically, there is a key exchange that happens between the controller software and this software that actually controls the brakes or any other system. So only when the key exchange is successful, right? So when the controller is the main controller, the ECU main ECU is satisfied that the application is actually approved application, then only it will allow you to run that application. So it basically is so important because, for example, assume that you have a car and somebody can control your brakes, right? So then it is hugely hazardous. You can see that. Similarly, I mean, today embedded systems are there, like I mentioned about the patch, which you can apply on your body for insulin. I mean, pacemaker, which is basically helping you. I mean, I'm sure you've heard about pacemaker, right? So if somebody can get into that, it's hugely problematic. So there's basically encryption, decryption mechanism. Basically, embedded security is a big topic today, and I'm sure embedded security. If you go over the net, you can see a lot of information about that. So, I mean, other threat is, for example, you have a system. For example, if you know about debug, right? So every system has a debug capability. So if somebody can copy your code, right? So basically through the debug, you can access anything and everything because debug is having the highest privilege level in any system, right? So if you can connect a JTAG based debugger, if somebody can copy all your code, then they can actually develop their own embedded system with that code, right? But fortunately, debug has come out with the security. So again, either encryption, decryption mechanism or password-based mechanism or different kinds of mechanisms have been used even in that space, right? So nobody can just copy your embedded system or basically connect a JTAG probe and make the embedded system to work haywire, right? So through the JTAG, you can actually write to any, like I said, it has highest privilege. It can actually access any of the registers or memory that is available, right? So through this mechanism of debug security, right? So nobody can actually get into that. So that is through debug, and I spoke about already through network. If somebody has to come in, for that also there is a mechanism that is already available. Any application cannot just run, especially the safety critical application, right? It cannot just run when it is just installed, but it has to comply to certain security norm. Like I said, there has to be a key exchange. Only when the key exchange gets satisfied, basically there is a proper key exchange, then only the application is authorized to run, right? So these are the mechanisms that people have implemented already, and in fact there is a good amount of support that is available even in the processor architectures today. That's one of the reasons I was also telling you that you need to understand the processor architecture well so that you can have a good understanding of these.
Okay. Thank you so much. I'm sure the crowd might have got this things properly. And yeah, that's it. Thank you so much, sir.
Thank you.
Thank you so much, sir, for delivering such a comprehensive and thought-provoking session on embedded systems. The insights shared today on system design and the role of embedded technologies in powering smart devices have given us a deeper understanding of this domain, and I'm sure learners would have gained some insightful information out of this session. I would like to thank the Maven Silicon team for curating this session well, and I would also like to thank all the participants for attending this session. And I also look forward to having you all join the upcoming masterclasses by SWAYAM Plus. Until then, thank you all. Thank you so much for joining us today. Thank you so much.
Thank you, Lavanya. Thank you, everyone. Have a great evening.
Have a great day. Thank you.